I love chocolate. It's pretty yummy and gets a 10 out of 10. But what is chocolate made of, and what do chocolatiers mean when they say they're tempering chocolate? Before we dive into the process of tempering chocolate, let's briefly describe the process by which it's made. The process of making chocolate is actually quite long and difficult. You first need to ferment cocoa beans. Then they need to be dried until they only contain 6 to 8% moisture. This prevents them from going moldy and makes them easier to store and transport. These steps are done at cocoa plantations before the beans are shipped off to chocolate factories. After arriving at a chocolate factory, the beans are then roasted at a temperature between 120 to 140 degrees Celsius. This step is responsible for producing the distinct flavors and aromas of chocolate while getting rid of the contaminants in the beans. Then, some of the beans are ground to form cocoa liquor, and some of the cocoa liquor is pressed to form cocoa butter. The beans, the liquor, and the butter are then mixed together, and in the case of milk chocolate, milk and sugar are also added. After this comes the process of conching, which involves heating and more mixing. The agitation coats all of the solid particles with fat, forming liquid chocolate. Conching also removes extra moisture from the chocolate and helps the chocolate develop a nice color. And after this, you have chocolate. I'm sure it comes as no surprise that one of the main constituents of chocolate is cocoa butter. Cocoa butter mainly consists of oleic, palmitic, and stearic fatty acids, and they're responsible for giving chocolate its physical characteristics. When chocolatiers temper chocolate, they're actually messing with how these cocoa butter particles are arranged. Cocoa butter is what's known as polymorphic, a fancy chemistry way of saying it can crystallize in more than one form. Another example of a substance that's polymorphic is carbon, which naturally exhibits two different crystalline structures, depending on environmental conditions, with two very different sets of physical properties. Carbon in a hexagonal structure gets you graphite, but carbon in an isometric structure gets you diamond. Cocoa butter could exhibit 6 different crystalline structures, numbered 1 through 6. Ideally, we want crystalline structure 5, and only 5 because it's glossy, firm, has a nice snap, and doesn't melt too easily. In order to achieve this ideal structure, chocolatiers go through a long process that involves heating up and cooling chocolate to very specific temperatures, and it's this process that's known as tempering. First, the chocolate is heated to 50 degrees Celsius, which is hot enough to eliminate all 6 crystalline structures. Then, the chocolate is cooled to 27 degrees and agitated, allowing crystal structures 4 and 5 to form. After, the chocolate is reheated, this time to 31 degrees, to eliminate crystal structure 4. Structure 4 crystals melt at a lower temperature than structure 5, and so a temperature of 31 degrees is perfect for getting rid of structure 4 crystals while keeping structure 5 crystals intact. As you can imagine, this process can be pretty finicky. Even slight deviations from these temperatures can totally wreck the process. This is why sous vide machines are sometimes used to temper chocolate, as they allow for very precise control over the temperature to which the chocolate is heated or cooled. Other methods of tempering chocolate include the seeding method, wherein tempered chocolate is stirred into molten chocolate. The preformed crystals in the tempered chocolate seed the molten chocolate and help it develop the proper type 5 crystals. There's also another method called the tabling method, in which about 75% of a batch of molten chocolate is poured onto a cool surface and then worked with something like a palette knife until it thickens, which indicates the formation of crystal seeds. Then, this cooled chocolate containing the proper type 5 crystal seeds is gently warmed when it is stirred into the rest of the batch. So, that's the sweet science behind chocolate and how it's tempered.